Hello and welcome to the second video portion of quantum key distribution. My name is Hunter Rath. I'm a graduate student at the University of Dallas. The purpose of this video is to explain two solutions to the weaknesses described in video 1. The first weakness and solution we will discuss deals with the number splitting attack. In a number splitting attack, the transmission between Alice and Bob is intercepted by Eve. If the transmission sent by Alice contains two or more photons, Eve will split off one for herself to measure while forwarding on the other to Bob. If the transmission between Alice and Bob contains only one photon, Eve will suppress the photon so Bob does not have access to any transmission that Eve does not have. Because quantum key distribution in real-life scenarios occurs over less than perfect transmission mediums, such as open air or fiber optic cable, Alice and Bob will likely assume the loss of part of the transmission is caused by background noise or absorption. The way Alice and Bob can thwart a number-splitting attack is through the use of decoy states, which occur when Alice purposely transmits a pulse which contains more than one photon. Eve will be unable to distinguish the decoy states from the real states, and thus will continue to forward these decoy states to Bob. As we can see in this short example, Alice will randomly inject decoy states into the transmission, which will be forwarded by Eve to Bob. By measuring the frequency at which the decoy states are received by Bob, compared to the intended key states, Alice and Bob will find that the decoy states are received at a higher percentage than real states. This will alert Alice and Bob to the attack by Eve, and communications will be severed. Research done at the University of Toronto has not only proven that decoy states can protect quantum key distribution from number splitting attacks, but can also be used to increase the maximum transmission distance. Quantum key distribution using decoy states, seen here as the red line, have achieved transmission distances over 140 kilometers. While standard quantum key distribution has been limited to only 30 kilometers. Decoy states allow for greater transmission distance because they allow Alice to increase the power of her transmitter, which allows for stronger signal which produces more multi-photon states, while still being able to detect an eavesdropper using a number splitting attack. The next weakness and solution we will discuss deals with the timing attack. Unfortunately, it is difficult to visualize exactly how this attack and solution take place, so I will attempt to demonstrate it as best as I can. In the timing attack, Alice measures timing delays that occur within the equipment of Alice and Bob. Obviously, manufacturing higher quality equipment will help to mitigate this risk. However, this is a very costly approach. Alternatively, Alice can send Bob transmission pulses at random intervals. Random intervals will make it impossible for Eve to predict when the transmission pulse was generated or received, because she will be unable to distinguish them from background noise. Without knowing exactly when the transmission was sent or received, Eve will not know when to measure delays within Alice and Bob's machines, thwarting the attack.